A function describes the relationship between an input and an output such that each input has only one output. Let's take a look at what that means. First, some examples of functions that you might see. F is a function of x, g is a function of x or g of x, and h as a function of x. These are all very common functions. Most commonly, though, you will probably see f of x. Now, y is equal to f of x. And f of x can be anything if I can put in an x value and get out one f of x value or one y value, one output value. Say it could be 2x minus 5. That would be a function. I could put in an x and get out a y. So looking at this one, the x value again is the input. It's the number we put in. The y value, or the whole f of x value, which would be this, is our output. For it to be a function, every time I plug in an x value, I can only get out one y value. So if I plug in, let's say 2 for x, I can only get out one answer. If it gives me two numbers back, then it is no longer a function. Now let's look at this a bit more practically. We're looking at function tables. Let's say we have y equals 4x plus 1. Remember that y can be equal to f of x. So let's come up with some inputs. Let's say we want x to equal 1. Remember, x is our input. So we would input 1 for x, and that would give us y equals 4 times 1 is 4 plus 1 is 5. So if I plug in 1, my output will be 5. Let's say we want x, our input, to be 2. We will plug in 2. And our output will be 4 times 2 is 8 plus 1 is 9. So if we plug in 2 as our input, our output is 9. Let's do one more. Let's say x is 3. Y equals 4. We would plug in 3. 4 times 3 is 12, plus 1 is 13. So if our input is 3, our output will be 13. And that is a function. But let's say, for example, what happens if we plug in 2 and we got two answers? What happens if we plug in 2 and we get y equals 9 and y can also equal, let's say, 15? If you saw this in an ordered pair, it might say that a graph has the points 2, 15 and also 2, 9. This is no longer a function because we have one input, 2, but we're getting out two outputs. We cannot have that. So this is no longer a function. Try this question. Which one of these is not a function? Let's take a look at number 1. For our inputs, we have 1, 3, and 6. For our outputs, we have 2, 8, and 12. Now each input has one output. So this is a function. Forgive my handwriting. Number 2. Is this a function? Well, let's take a look. For our input, we have 2 is negative 5, 3 is 6, oh, and we have 2 is 7. we have an input of 2 and an output of -5. We have an input of 2 and an output of 7. This is not a function. Because we have input 2, one input is giving us 2 outputs. We cannot have that. Now let's look at number 3, just to check. We have 2 is -5, 3 is -5, and 4 is 7. Now this is a function. Well, you might be thinking, well, there's these 2 outputs repeated. And just to have a function, outputs can repeat, but none of the inputs can have more than one output. So inputs can have the same output, but inputs cannot have multiple outputs for the same input. I hope that makes sense. Let's take a look at these 3 graphs. Are they functions? One way that you can tell that if a graph is a function is by drawing or doing a vertical line test. This means that you draw a vertical line through the function and see how many times it crosses the function. If it crosses the function once, it is a function, but if it crosses the graph more than once, it is not a function. If we look at this, it crosses our graph here and it also crosses our graph there. So this cannot be a function. Now let's think of this in terms of inputs and outputs. I have one x value right here. Let's say that's 2. That's giving us the point 2 in a positive y. That might be about at 1. And that's giving us 2 for a negative y. Say that might be about at -2. We have one input, 2, one x value, but we're getting out 2 y values. As we can see, we have one input, 2 outputs. That causes us to fail the vertical line test because we cross the graph more than once. So this is not a function. Let's take a look at number 2. This one, if we draw a line at any given point, it only crosses it once. Crosses it once, crosses it once, crosses it once. There is nowhere that a vertical line will be able to cross this graph twice because each x input only has one y output. So the line can never get doubled over like this one is so that we cross it more than once. Or even if we had something like this, that would obviously not be a function. But if we have one output for each x input, that can't happen. And that's what happens with this one. So this one is a function. Now let's take a look at number 3. Again, if we draw a vertical line through this graph at any point, doesn't matter where, it has to be anywhere, we only cross the graph once. We never cross it twice. But then, again, imagine if this graph was, let's say, turned, so it was like this, that would no longer be a function because we would have multiple y values for the same x value. But because it's the way it is, and the vertical line test says I can only cross this graph at once, one point, this is a function. It passes the vertical line test. And I really hope I explained that so you can understand why the vertical line test works. It's really a matter of having one output for each x input. Because if I have an x input, let's say right there, and then I get 2 outputs, I'm going to end up with an output, say there, and I'm going to end up with an output there. And that's going to make me not pass the vertical line test because I'm going to cross that graph multiple times and it won't work. So for it to be a function, for it to pass the vertical line test, we can only have one output for each input. I hope you found that helpful. I will be making more videos on these in the future. Thank you so much for watching. If you have any questions, please let me know. and I will see you next time.